Before the video begins, make sure you've subscribed to see more natural history content like this. Hit the bell icon to keep yourself in the loop, and leave a comment if you feel like it. Brand new designs are up on the Edge Redbubble. Werewolves, spiders, FedEx amphibians, proto-crocs, and more. Go check out the Redbubble with links in the description and comments section below. Frank Herbert's Dune series is easily one of the most influential pieces of science fiction ever written. Essentially, all your favorite pieces of sci-fi pop culture take some inspiration, however small, from these tomes. Herbert lavishly outlined and described an incredibly rich universe, in which a great many human feats and developments have occurred over the next tens of thousands of years. All of it centered around the desert planet Arrakis, inhabited by titanic sandworms, which help to produce a mind-enhancing drug called spice. The planet of Arrakis is explored in such luscious prose that one might easily imagine themselves there. If the planet was real, would we really be able to live there? A group of climate scientists decided to simulate the climate of Arrakis to find out just how survivable the place would be. They intended to observe if the physics and environment of Arrakis could stand up against real-world climate models. They came up with this visualization of their climate model. You can readily access this simulation through their website, Climate Archives. So, what did they find out? They found that, for the most part, Herbert's imagination and description of said imagination pretty much meets expectations. Turns out, much of Arrakis would be habitable, though quite inhospitable. Us humans have learned to live in some truly inhospitable places, so I wouldn't take that part too harshly. So, how did they do it? The scientists started out with a climate model used for Earth. What better way to make a climate model of a somewhat Earth-like planet than to use an Earth model as a base? In order to make a model like this, you need to know the physics of the thing you're making, so the program can create proper parameters for the model. The physics of Earth, I would hope, are well known at this point, but less so for a fictional planet like Arrakis. From there, you need to insert information about mountain ranges, strength of the sun, makeup of the atmosphere, and more. Once all the exact parameters are known and entered, the program can begin to create a mostly accurate model of your thingamajig. The group decided to keep the same fundamental laws of physics that govern our planet and its weather and climate. They did this despite the extraterrestrial nature of this planet because they could see whether the physics of Arrakis are drastically different from Earth by inputting all other known details about Arrakis. If the model popped out super bizarre, it would show that the physics are different and that the team would have to go back in and edit the physics. On the flip side, it could also just prove that Herbert was just doing some fantasy world building, which is fine. Information on the planet's topography, orbit, and atmosphere was collected from the books, plus the maybe canon, maybe not canon Dune encyclopedia. Turns out the orbit of Arrakis is meant to be essentially Earth-like, which is more or less circular. The shape of a planet's orbit is incredibly important to the climate of the planet as a whole. An example in fiction would be the super long, oblong orbit of the planets in Game of Thrones, resulting in those long winters. The atmosphere, as described by the text, was reconstructed by the climate scientists as similar to present-day Earth's atmosphere, though they decreased the level of carbon dioxide on Arrakis from Earth's 417 parts per million to 350 parts per million. The largest difference is the ozone. Earth's ozone is 0.0000001%, but on Arrakis it is increased to 0.5%. Ozone is way more effective at warming an atmosphere than other greenhouse gases like CO2, as it traps and bounces radiation around the atmosphere at 65 times the efficiency. That would help to explain part of why Arrakis remains a hot desert world. Turns out, Arrakis Climate is plausible. The books and film describe the inhospitable nature of most of the planet in detail. There's unforgiving sun that beats down on wastelands of sand, rock, and creosote bushes. It changes only a little bit as you move towards the planet's poles. This is where the cities of Arrakis and Carthage are placed. The climate changes around the poles to be slightly more hospitable, but no less uncomfortable. That's how it's described in the literature, but not how it appears in the climate model. In the model of Arrakis, the warmest months in the tropic regions reach 45 degrees Celsius 113 degrees Fahrenheit and drop down to 15 degrees Celsius 59 degrees Fahrenheit in the coldest months. That's not horrifically off from Earth's temperature range. The most extreme temperature ranges occur in the mid-latitudes and polar regions. Summer rockets the region to 70 degrees Celsius, 158 degrees Fahrenheit, and winters plunge to negative 40 degrees Celsius, negative 40 degrees Fahrenheit in the mid-latitudes, and negative 75 degrees Celsius, negative 75 degrees Fahrenheit at the poles. The climate scientists describe this as counterintuitive, as the equatorial region should receive more energy from the sun. In the computer model, Arrakis was found to have more moisture and higher cloud cover at the polar regions, which should act to warm the climate. Water vapor is also a greenhouse gas, go figure. On top of that, the books are explicit on Arrakis having no precipitation. Contrary to the book's lore, the climate model predicted that small amounts of rainfall would occur on the planet, only at high latitudes during summer and fall on mountains and plateaus though. Clouds should be found at the subtropics and poles, varying from season to season, but little to no actual rain. According to the books, the planet is supposed to have ice caps in the northern hemisphere, and they've been there for a long time. This is one of the biggest differences to the climate model, as the presence of ice caps would impact both the climate and topography of the planet if they were present. The climate model also suggests that no ice caps could exist without completely melting away, and it wouldn't get cold enough with enough humidity for snowfall to occur to replenish those ice caps. Now that we have an idea of what the planet is like to live on, could humans really survive? Of course we could. With enough tech, planning, and knowledge, we can basically survive most things. But that doesn't really explain whether or not our simple biological functions could survive the onslaught of the environment. So what about that? Assuming the people of Dune have the same or somewhat similar thermal tolerances as humans today, the tropics would be the best place for humanity to remain. This is in contradiction to the mid-latitude and pole-located cities of the books. The Arrakis model suggests that wet bulb temperatures, a measure of habitability combining temperature and humidity, are never exceeded at the poles. Mid-latitudes are the hottest and most dangerous. The temperatures predicted by the model of 50 to 60 degrees Celsius are straight up deadly to humans. Frank Herbert had his Arrakis humans invent the stillsuit, a one-piece bodysuit stuffed with tech that retains all moisture lost by the body and cools the body against the ultra-high temperatures of the planet. Outside of the habitable regions of the planet, humans must wear these suits or death be the result. So, without a suit, only parts of the planet would be habitable, and with the suits, humans can survive on the entire planet both in the books and in the climate model. Though the uninhabitable places with a suit are probably still super uncomfy, and I wouldn't want to be caught dead there. How about you? Would you be fine living like that? Plenty of people do today, though no places quite reach 158 degrees Fahrenheit yet. Of course, there's always time for that. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, hit the bell icon for updates, like this video, and drop a comment in the comment section below. Thanks for watching. Special thanks goes to my Elephant tier patrons, Thea Svensson, Staniforth Hopkins, Dinosaur, Chris Frampton, Biotaverse, Arda Bayer, and Christoph Hubbinger, as well as my Tyrannosaur patrons, Iron Bladesman, Henry Brennan, Danny Van Heck, and Dana Manchester.